hello, and welcome. It's your main math man, Mr. Lyons here. Hope all is well. And today we're understanding bivariate data by constructing and interpreting. So we're going to build and then interpret scatter plots, right? And this is one of my favorite lessons of all time because it has so many real world applications and you can tell relationships between certain things. Bivariate data involves how many variables? You see that word bi in there. Think of a bicycle. How many wheels does a bicycle have? Two variables. We investigate bivariate data to see what kind of relationship between two variables, right? So you have the bi-two variate variables. This kind of data is used a lot in real world. Oh, what did I just say? Especially in science and social studies, right? And so does studying improve your math score? So Mr. O'Brien, I'm going to paraphrase a little bit here because you should have read this already. Mr. O'Brien here, he's a teacher at the high school. He's looking at the relationship between what, right? We're talking about how many variables? Two variables. So we're talking about the relationship between what two things here? The relationship between scores on an algebra exam, right? And the amount of time they spent studying for it, right? So students studied for the test. You do practice problems. You go on a website. You record the minutes. Yeah, that's how you gather the data. And then you record the number of minutes, and then you see the test scores, right? So let's take a look here. We're going to create a scatter plot, and it's called a scatter plot. It's an important word there because some of the points are going to be scattered everywhere, right? And as I'm describing how I design my graph, I want you to pause the video if you need to, catch up with the graph, and I'm just going to describe how I decided to scale here, right? Because you're going to be what? Constructing these scatter plots on your own. So I notice I'm given a table. Thank you. I'm given a table here, and time is usually time is usually X, and then Y comes next. And, this is an XY table, so it's pretty organized for you already. I make sure I label my table, and I decided to count by tens because this is how Mr. Lyons does it. I look at the highest score here for minutes. Highest minutes. I see the highest minutes is 99, rounds out to about 100, and I count how much my graph that I'm given is scaling by. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 100 divided by 12 is about 8, so I rounded that to 10 to make it nice and even, so I just counted by tens here to get to 120. And I labeled my x-axis. Go ahead and pause the video and do that now. Same thing for my Y's here. The highest you can get on a test is 100. Sometimes it's extra credit. But on this chart, it's 100, and I counted again, and I scaled it out. It's about 12 scales. And so I said, well, 100 is the highest, divided by 12 is 10, so I did it again. I just counted by tens here. Pause the video, make sure you catch up. All right? So that's how I usually construct. I see what's the highest I need to go to, and then I divide that by what I'm given. How many jumps I need to make, right? Makes sense. And before I go ahead and plot, it's important that when you're graphing your ordered pairs, we're representing data, not just numbers. So what should I label my x-axis? Yeah, this is the number of minutes. And notice that I did this in pen, and then I paused and I saw, wait a second. What if I make a mistake? This is math. Let me change to pencil, right? And then Y is the test score. Now, before we start plotting this, I want you to think, right? And this is why I talk about real world situations. Do you think there'd be a relationship between number of minutes studied and excuse me, let me be more specific. Number of minutes studied and the score you get on the test? Do you think there should be a relationship there? Well, we're going to see. This is what scatter plots are for. So 60, 85. I'm going to go to 60. And then I'm going to go up. 85 would be right in between 90 and 80. And for scatter plots, it's okay to sort of estimate here. I know when we did linear equations, you need to lattice points to be as specific as possible. But it's called a scatter plot for a reason, right? Some of these plots might be scattered plots. And I put a little check here to know I'm done with that, right? Staying organized. 65, 85. I'm going to go ahead and go to 65, right in between 60 and 70. Go up to 85. Oh, look at that, right? I'm going to do one more together, and then I'm going to want you to pause the video. Then I'm going to want you to do it on your own, and then you should see on the next slide what it should look like, right? 70, 90, 70, 90, 70, go up to 90, all right? So we did the first three together. Go ahead and do the rest on your own, and then I'll check you in the next vid.